All right, let's talk about scientific notation. This right here is written in scientific notation. And what I want to do is put it in standard notation. And that's just basically how we've seen numbers our entire lives. When I'm multiplying times 10 to the fifth, that's the same thing as saying times 10, times 10, times 10, times 10, times 10, right? That's 10, 1, 2, 3, 4, 5 times. And remember, when we're multiplying by 10, that's the same thing as moving your decimal to the right. And so in this case, I'm going to move my decimal to the right 5 places. So I'm going to write 1.35, and then I'm going to move this 1 spot, 2, 3, 4, and 5. So I'm basically erasing my black decimal there. Oops, I tried. 1, 2, 3, 4, 5. And then you're going to put zeros in for where you don't have any numbers. So this is equivalent to 135,000. Technically, you've put your decimal here now, but that is the same thing as 135,000. All right. Let's try another one. 2.7 times 10 to the negative 3. Well, times 10 to the negative 3 is the same thing as saying 2.7 times 1 over 10 times 1 over 10 times 1 over 10, which is the same thing as saying 2.7 divided by 10, then divide by 10, then divide by 10. So what we're going to do here, when we're dividing by 10, we're moving our decimal to the left. And in this case, we're going to move it over 3 places. So this will be 2.7 times 10 to the negative 3 means that I'm going to take my point and go to the left 3. So let's see what that looks like. 1, 2, 3. So I put in zeros here. I get rid of my decimal, and my answer in standard notation is 0.0027. So these two things mean exactly the same thing. This here is scientific notation, this is standard notation. All right, maybe pause the video and see if you can get this one correct. All right, let's see if you got it right. You took your negative 2.01, and then since it's a positive 4, you're going to the right 1, 2, 3, 4, putting your 2 zeros in, and you are left with a negative 20100, which is negative 20,100. I'm going to try to erase this. Oh, I did it perfectly. All right, so these two things are exactly the same thing. All right, I think last one before we try something a little bit harder. So I'm going to go from 2.87, and I'm going to move my decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 0, 0, 0, 0, 0, 0. Erase that decimal. Missed it again. And what do I get? 287, 1, 2, 3, 4, 5, 6, 7. Then bring my commas back by 3, and I'm left with quite a large number. So that's the reason why we use scientific notation, because it can be written a lot smaller than something like this. Let's go the other direction. How do I write 0.00709 in scientific notation? Well, I know that that's going to be 7.09, because we always want to have it as just a number less than 10, times 10 to the what? Well, let's go ahead and figure out how far we'd have to move our decimal back. Well, we'd have to go left 1, 2, 3. So this would be times 10 to the negative 3, because I'm going backwards with my 7.09. So that's our answer for this problem. Okay, how about this one? Well, we know the answer is going to be 8.11 times 10 to the something. Well, what is that something going to be? Let's figure out how far left we have to go with 8.11. We'd have to go 1, 2, 3, 4 to the left, so times 10 to the negative 4. And that would be our answer. All right, let's talk about estimating answers with scientific notation. You and your friend are doing a rough calculation of how much garbage New York City residents produce every day. You estimate that on average, each of the 8 million residents in New York City produce 1.8 pounds or 0.009 tons of garbage a day. So you're trying to figure out how much garbage New York City residents produce every day. So you would want to know the number of New York City residents. And each of those residents produces 0.009 tons of garbage a day. So we're going to multiply by 0.0009 because each of these residents makes this much trash, and that will tell us how much total trash is produced on a daily basis. Well, what I'm going to do is I'm just going to research the number of New York City residents, BRB. Okay, I just went to the internet and I found that the number of New York City residents is 8,336,817. However, I'm really just estimating, right? You're doing a rough calculation, so I'm just going to call this 8 million. So I'm going to do 8 million times 0.0009. Now, what if I asked you to not use a calculator and solve that problem? I think a lot of you would panic. Well, if we convert this into scientific notation, it's actually a pretty easy problem. So we're going to write this as 8.0 times 10 to the something times 9.0 times 10 to the something. All right, well, if I want that, let's pretend my decimal is here. We have to go 1, 2, 3, 4, 5, 6. So it'd be 8 times 10 to the 6th. And here, if I had 9.0, I'd have to move my decimal left. 1, 2, 3, 4. So to do this problem, all you have to do is multiply 8 times 9, and you get 72. Times, and then our exponent rules, if you remember from Algebra 2 or Pre-Calc, says that if I'm multiplying 10 to the 6th times 10 to the negative 4, you're just going to add 6 plus a negative 4, which is 2. So our answer is 72 times 10 to the 2nd, and 72 we can write as 72.0 times 10 to the 2nd means that we are going to move our decimal over 1, 2. All right, so then our answer is going to be 720, and I got to put another 0 here. So 7,200 tons of garbage a day in New York City. Think about how many tons is a garbage truck and how much waste that is. That's unbelievable, isn't it? All right, moving on. Oh, I just did a lot of slides here. All right, next one is estimate 4 million roughly times 0.008. So here we'll have 4.0 times 10. Let's just completely ignore this, right? We don't, if we're estimating, who cares? It's 567. So 4.0 times 10 to the 1, 2, 3, 4, 5, 6. So that 4.0 times 10 to the 6 times 8.0 times 10 to the, well, if this was an 8.0, we'd be going left 1, 2, 3. So times 10 to the negative 3. Well, what's 4 times 8? That's 32. And that's going to be times 10. Well, what's 6 plus negative 3? Well, that's just going to be 3. So our answer is going to be 32 times 10 to the 3. So I'm going to take 32.0. And I'm going to move this decimal 1, 2, 3. So I'd put a 0 and a 0 here. So then that decimal here disappears, and I'm left with 32,000. And our actual answer is 32,004. So we're pretty darn close, aren't we? How about this one? Let's estimate this. Well, I'm going to change this to a 0, 0, 0, 0, 0, 0. So this is going to be 2.0 times 10 to the, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 2.0 times 10 to the 9th. And then this I can think of as 1.2. Well, I'd have to go left 1, 2, 3. So left 3. If you're confused about should my number be positive or negative, if it's a big number, this should be positive. If it's a decimal, this should be negative. All right, well, what is 2 times 1.2? Well, that's obviously 2.4. And then it's going to be times 10. Well, what is 9 plus a negative 3? Well, that's going to be a 6. So now I'm going to take this 2.4 and I'm going to move my decimal over 1, 2, 3, 4, 5, 6. All right, and then that's going to become 2, 4, 0, 1, 2, 3, 4. And then put your commas, and I'm left with 2.4 million. And the actual answer is 2.5 million, but we were just estimating. All right, last question. Mrs. Dodgy claims that 5,796 times 326 is less than a million. Show that she's wrong using scientific notation. All right, well, she says it's less than a million. Well, let's just round up and say 6,000 times 400. Well, this is going to be 6.0 times 10. Okay, what would 6.0 times 10 to the 1, 2, 3? And then there would be times 4.0 times 10 to the, okay, here's my 4.0, I'd be going over 2. And again, remember, these are positive because my numbers are not decimals. They're greater than 1. Well, 6 times 4 is 24. And then this is going to be times 10 to the, what's 3 plus 2? That's 5. So that's 24. And then I'm going to move my decimal over, we can call it 24.0 if you want. 1, 2, 3, 4, 5. Okay, so that's going to be 1, 2, 3, 4, 5. Okay. So then I've got 2, 4, 0, 1, 2, 3, 4, and we see that that is 2.4 million. You could also have tried this problem with 5,000 times 300, and let's see what we get there. That's 5.0 times 10 to the 3rd times 3.0. Right, we're going to round down 3.0 times 10 to the 2. 5 times 3 is 15, times 10 to the 3 plus 2 is 5. So we're going to take this 15.0 and go 1, 2, 3, 4, 5. And that's going to give us a 15 with that. And I'm left with 1.5 million. So even when I rounded down, I got 1.5 million. When I rounded up, I got 2.4 million. I think the better one to say is, hey, even when I rounded down, you get 1.5 million. So there's no way that this answer is less than a million. She has a disease. It's called diabetes. Thanks for watching. Peace out.